Yeah, so good evening, everyone. I'm Parth and I'm representing Group 4 in our operating systems lab final project. So, what we have developed is a portal, or you can say a website, that will give you access for four algorithms. So, we have worked upon round robin, bankers algorithm, SCAN-CSCAN, and most recently used page algorithms, right? So in that we have done this. So on the main menu, we have kept all this because it would be easier for the user to access our programs, right? So okay, first moving on to round robin, we can see what round robin is, that we provide few processes, and in that what we do, we define a time quantum, and if our process is less than that time quantum, it will get finished then. But if it isn't, it will wait till the complete execution of other processes, right? So here's a little bit theory about it, and we'll just go to the simulation. So yeah, we will be redirecting it to our round robin algorithm. So here we can place three processes. So as you can see, it dynamically arranges it. So then we'll just keep time quantum as 5, and arrival time, let's just keep 0, 1 and 2. After that we'll keep burst time as, let's just say, 3, okay, 6 and 2. We'll run it, and as you can see, our code is getting executed. So let's just wait for a minute. Okay, all right. I guess it will take a minute, so we'll just carry on and you know watch the algorithm. So okay, so this is our speciality about our website, that we have placed an algorithm here. That too, cause we need easy accessibility to other algorithms, right? So we'll just move on to bankers. You can see here, bankers algorithm is placed here, and we can what why bankers algorithm is used. So basically it's used for resource allocation and avoidance of deadlock. In our simulation we have provided two examples for the same, and it has various use cases to it. So let's just move on to the simulation part, and let's see. Okay, so here we can define instances on our each resource. So you can see the tables: allocation, maximum, available and need. So for that, we have kept deadlock. So let's just click deadlock, and because we why we have kept these, because there are many inputs that are required here. So just to be easier on the users, it's done that. So let's just run our algorithm. Okay, we'll click on, and you can see it prompts a deadlock. Clicking on OK, why it's a deadlock, right? So as you can see from the allocation table, that one instance is still left, and we can't process everything. So the process sequence, as you see, P2, P4, P5, P3, and a blank, cause it's a deadlock. Okay, now resetting the values, we'll put the example of a safe. Getting the example of a safe, as you can see, it has initialized the number of instances here and allocation 2. Okay, then we'll run the algorithm. See, the prompt says safe, and we'll just click on OK. And yes, yes, as you can see, in allocation, we don't have any instances left. That means that we have processed everything here. So as you can see, the sequence is also there. Yeah, so that was Banker's algorithm. Now moving on to SCAN-CSCAN. So basically, SCAN is known as an elevator algorithm, and it's used on while reading the disk and writing things on it. Uh, Another implementation of SCAN is CSCAN, also known as circular scan, that's used to uh, do the disk reading and the scheduling. Okay, so we'll just move on to our simulation. Getting on the simulation, we have few things that are here. So first, the head position. Head position is something that we will start with. So let's just keep 50 for time being. Upper bound can be dynamic, and we can keep it as 199. And yeah, we need to keep a requested array. And it need not to be in a specific order, increasing or decreasing. Let's just keep random numbers like, okay, 30, 40, let's just keep 34, 112, 177, and 56, right? So as you can see, we have selected scan, and let's just, right, okay, let's just keep left. Right, so as you can see, the graph that has been generated here is for left. As you can see, it goes till the very end and then goes till another, like not the maximum, while coming from the zero, and we'll just turn it to C-scan, that is circular scan. And for circular scan, total seek time is more than scan, so let's just switch it to that. As you can see, we get a seek time of 398. As you can see, it goes on till the very maximum number and then drops to zero, as we can see here, right? And drops to zero and then covers the rest of the points that are, laid out. So yeah, this is a simple application that we can, visualize through what goes on really in our disk. Moving on, we have a last algorithm, that is MRU. So basically what MRU stands for is the most recently used page replacement algorithm. What this does is, we just place our pages on a queue, and when we are inputting the next queue, it just replaces the most recently used queue. So we'll just go on to the simulation. Yeah, so we can see here number of frames will just keep 4, and keeping a reference string, let's just keep 7, 6, 4, 3, 5, okay, 5, 4, 7, 2, 1, and 8. Yeah, then we'll just click on simulate. When we simulate, yeah, we can see that number of hits are 2. Why number of hits are 2? Let's just analyze that. So first we have, 7643. So it just got populated in our queue, 7643. Then 5 came. So when 5 came, 3 got replaced because it was the recent one, right? After 5, it came 4 came, but 4 is already in our queue. So that's why we call it a hit. After 4, we have 7, and 7 is also in our queue. So that's another hit. So we've got 2 hits there, and after that, there isn't a recurring number that's already in our queue. So that's our algorithms. Now, about our team, we are 5 members in our team that have contributed to this project, as you can see from here. Now, the X factor about our project is that we have integrated a chatbot in our application. So basically what you can do is ask any question to it. So let's just ask, what is banker's algorithm in 2 lines? So what we have done is